Okay. Um, so in the previous class, we learnt about different contention-based reservation protocols, and very specifically we looked at a protocol called DPRMA, which is basically a distributed packet reservation multiple access protocol. Now, what are we trying to learn? We are now trying to learn different contention mechanisms by which we are able to allocate a channel. We are right now looking at MAC protocol, and we are basically looking at, in the MAC protocol, how we can allocate the channel. And the theme in which we are exploring is contention based protocols. So that means there are different nodes, and each nodes basically tries to contend within each other to reserve a particular channel. How do they do it? They reserve a particular slot. So we are basically looking at what are the different reservation mechanisms that are available for the contention based protocols. Initially we learned something called as DPRMA, alright, and then we have basically understood what are its specific applications. And you remember I told you that this DPRMA is very good for the voice supporting applications. So any applications that have voice triggered applications, then we would basically prefer a DPRMA. Alright, so today we will look at few other protocols which are of relevance in nature, which also basically talk about are contention based protocols. Okay, so what is that we are going to learn today? We are going to learn a protocol called CATA, which is called as CATA protocol. Alright, so what is CATA? CATA stands for Collision Avoidance Time Allocation Protocol. Alright, so what is this protocol? This protocol basically supports broadcast transmissions, unicast transmissions, as well as multicast transmissions. And these protocols are based on a dynamic topology, and it is completely dependent on the transmission scheduling. Alright, so that means this can cater to the dynamic topology environment. So if the topology is really dynamic, this can really help us to do it. Now, how do it reserves the slot? Alright, basically the nodes content for, and they reserve certain time slots. Now how do they do it? They have two mechanisms. One is called as distributed reservation, and the second one is through handshake mechanism. So basically it's a handshake sort of a protocol, and it basically does through a distributed reservation concept. So we will now try to look at what is this handshake mechanism that basically takes place. You all know what's a handshake. Handshake basically we call it as a RTS, CTS, and then the acknowledgement. Once this complete process is taken care of, we try to send the data. The similar thing basically holds good for this as well. And they felt because of a very typical handshake mechanism, the collision is completely avoided, and therefore they basically say it's a collision avoidance protocol. Alright. So this also states that it's a time allocation protocol. That means the time is taken on the x-axis, and we try to divide into slots. So that's the objective. Okay, now what are the important principles that are basically lie down in these protocols? There are basically two principles. Number one is the receiver of the flow or receiver nodes must inform the source nodes about the reserved slot on which it is currently receiving the packets. So that means the receiver has the requirement to communicate to all the potential source nodes that there has been a reservation that has already taken place. Are you getting what I'm saying? And source node should also inform all the destination nodes or all the destinations nodes or whoever it wants to communicate about reservation of the particular slot. So there is two roles that are basically played by the two different nodes, basically one from the source node as well as from the destination node. The destination node basically says, hey, my reserved slot has been reserved and therefore don't try to send those packets. To whom? To all the potential source nodes. Alright, so in this present scenario, it's something like there is one receiver node and there are 5 nodes from whom packets may come. Alright, then the destination node should inform all the potential source nodes that okay, it's little reserved, alright, or the slots is busy. On the other hand, the source node should also inform that to all the potential receiving nodes that there is certain interference or there is certain reservation in the particular slots. Are you getting? So there is two ways of looking at it. And the second principle basically is it uses a negative acknowledgement for reservation request and control packet transmission at the beginning of each slot for distributing slot related information to senders of broadcast or multicast section. So it means that you try to send a negative acknowledgement. Alright. Positive acknowledgement is when you receive the packets, you are saying okay, I have received it, alright, and therefore the receiver sender will know that you have received the packet. Negative acknowledgement says, hey, I am already busy and therefore don't try to do it. So let's try to look at in detail about how does it operates. Okay, any doubts? My goodness, hand. There we are. Okay. So let us now look at this slide. The first part of the slide basically shows the frame format in the CATA. Alright. So what is CATA? Okay. Collision avoidance and time allocation protocol. So you will find that a particular frame which is divided into slots. Okay. Particular frame is divided into slots. And how many slots did we see there? Yes, number of slots. Am I right? Yes, that's right. Yeah. Okay. So how many? So this is a frame. Let us assume that the frame has a frame length of L. And it is divided into multiple slots. So what is the number of slots here? S slots, and therefore I have slot 1, slot 2 and up to slot S. Now let's look at each slot by slot to look at what are the unique features in each slots. So this slot is basically divided into a particular control related packets and a data related packets. Okay. Now what is CMS? Alright, it basically is a control related packet, CMS1, CMS2, CMS3, CMS4 and so on. So CMS1 basically is a slot reservation packet. Alright, so in the CMS1 you will find slot reservations happening. Okay, so that means if any node, a sender wants to send any packet, it has to first reserve a slot for him. Am I right? And that reservation takes place in the CMS1, which is a slot reservation. And then in the CMS2, once it reserves, so before it reserves, how it will do? It will look for whether the slot is free or idle. The slot is idle, alright, then immediately it pulls out or sends out a packet which is a slot reservation packet. So this has to be unicasted or broadcasted or multicasted. I am trying to reserve the slot. Broadcast. Okay, so it can either do a broadcast or a multicast because it says I am now trying to reserve a slot. Once it reserves a slot, alright, so no other can compete for that particular slots. Are you getting me? Then after the slot is reserved, then what it has to send? It has to send a request to send packet. To where? To the destination. So now the slot is ready and now I have to unicast that particular request to send to the particular receiver node. Okay, so when that does it, alright, the CMS3 slot is basically meant for the receiver to respond saying you are clear to send. Okay, so that is CTS. It's all okay. And once that is done, alright, clear to send, your data packet, you are trying to push the data. Are you getting what I'm saying? So that is called as DMS. DMS is a data mini slots. Alright, so that's it's a slot where you try to send your data. Now you find here that the data slots is not a sort of a fixed, so it basically shows it's a very lengthy one. So that means all these slots CMS1, CMS2, CMS3, CMS4, they are equally spaced. On the other, this is little bigger in space. So DMS is little larger in size compared to all CMS 1, 2, 3, 4 all put together, because that's basically a control slots. It's all clear? Now, what does the CMS4 stands for? CMS4 is basically a slot, mini slot, which is basically meant for sending a negative acknowledgement. Now, what do you mean by negative acknowledgement? Negative acknowledgement is you say that I am already busy and therefore all the others don't send it to me. Are you getting what I'm saying? So the receiver basically sends a note stating, hey guys, I'm quite busy because there is one person is already sending, and therefore you don't have to send me any data packets. Okay. Now let us assume you are able to do that and the data is getting transmitted. Let's now look at the next slot. Okay, so you can even do a subsequent slot as well. I'll continue with the same data transmission. Alright. So in that case, what will happen is the CMS3 and CMS2 will remain idle because it's already sending the data in that particular slot, and therefore in the CMS4 alone you will find NTS. Alright. And then you continue with your data transmission. So you find here there is a handshake. Am I right? Did you see a handshake here? Because you say RTS, CTS, and then it basically gives a distributed kind of a reservation mechanism. Alright. Now the question here is about the length of the frame. Now what is the length of the frame? The length of the frame is very, very crucial. Okay. Now how do I say about the length of the frame? The length of the frame is basically comprising of the number of slots. I basically said there is going to be S slots. But the question is, in each frame, what is the number of slots that you can basically have? Am I right? There is a simple formula, which I have not mentioned it here. Okay. Alright. So the concept is the number of slots in each frame should be greater than the number of 2-hop neighboring nodes of the transmitting node. Alright, let me read it or repeat it once again. The number of slots in each frame should be greater than the number of 2-hop neighboring nodes of a transmitting node. So that means considering the transmission node, the number of slots should be more than the 2-hop number of neighboring nodes. So we should count how many number of 2-hop neighboring nodes are available, and the number of slots should be greater than that. Now while if it is lesser than that, what is going to happen? Each nodes will not get an opportunity to figure out a slot for them to handle it. Are you getting what I am saying? So in order to provide equal opportunity, they are basically looking at a frame size where you have, based on the number of hops, a number of 2-hop neighboring nodes, you count the number of 2-hop neighboring nodes, and then you basically take a call on the number of slots in each frame. Are you all getting what I am saying? Okay. Now this basically works. So there is an interesting formula there. So the number of nodes okay, in each slot, okay, will be equal to, we should have a minimum of, okay, d square plus 1 comma n. Alright, d square. Alright, d basically talks about the degree. So it talks about the number of 2 hope neighboring nodes. So it talks about the degree at which these nodes are basically available. Is it all clear? Okay. So you will find that the CATA basically supports collision-free broadcast, and also it helps in the collision-free multicast traffic. Is it all okay? Now you have any doubts? Okay, now if you have no doubts, let's move to the next slide. Okay, we have few more protocols with the same reservation mechanisms. Alright, now the first one that we are going to talk about, not the first one, it's basically a fourth protocol. It's a hop reservation multiple access protocol. We will also learn soft reservation multiple access with priority assignment protocol also in the today's class, and with that we will try to wind up today's session. Okay, so what is hop reservation multiple access protocol? Okay, it's basically a multi-channel MAC protocol which is based on half duplex mode connection, and it basically looks at a concept of a very slow frequency hopping spread spectrum radios. So I'll tell you, if you have a spread spectrum of frequency, what does it mean? You have different frequency lined up, and then it becomes as a spectrum of it. Are you getting what I'm saying? Now what we try to do is we try to change the frequency. Alright, so we basically at a particular time we say this can operate at this particular frequency, and after a different time period it operates at a different frequency, and the next one it operates at a different frequency and covers up the spread spectrum. Are you getting what I'm saying? So that's the basically concept. Now how does it do it? I will still explain to you still further, you will be able to understand it better. It uses a reservation and a handshake mechanism. Alright, so to enable a pair of communicating nodes to reserve a particular frequency hop. Alright, so it basically tries to reserve a particular frequency hop in that particular frequency spread spectrum. Alright, it reserves, and then how does it reserve? It basically does a reservation for a particular pair of nodes. Alright, and then it basically goes ahead in transmitting the data. Thereby it guarantees collision-free data transmission. Okay. Now how can it be, has to be viewed? Alright, how is the slot and how we try to do it? We can basically say it's a time slot reservation protocol. Alright, so that means it has time slots, but in each time slot you have a separate frequency channel. Are you getting what I'm saying? So it's on a time slot basis. Alright, are you getting what I'm saying? So you have a time slot. That means for each time period, alright, a slot is there. Alright, and in that particular time slot, okay, we are operating based on a frequency operations. For example, at a particular frequency in a particular time slot, two different nodes will communicate. In the same time slot, alright, at a different frequency, at a different time, two other nodes will try to. So that's the concept. So how does it work? Let me show you a diagram. Alright, hope you are able to see this slide with clarity. So now look at this. This is a frame length, okay, which is divided into slots. So it's a time slot. Okay. Now assuming that there are m slots, alright, so you have slot 1, slot 2 up to slot m, and you find that there is something called as a synchronizing slot. Okay. Now I will tell you why do we require a synchronizing slot. Why do I require a synchronizing slot? Because there are different nodes, okay, and each node now have to synchronize themselves with reference to time as well as with reference to the frequency. So there is a slot meant to do that exercise. So basically, when it will help, when a new node joins. Okay, now let's assume that there are 5 nodes, and in a mobile ad hoc network there is always a requirement or a problem where many nodes can join that particular network and many nodes can leave that particular network. When many nodes leave, there is no problem because you don't have to allocate the channel. But when a new node joins that particular network, then we need to also give him a provision to contribute into the mobile ad hoc network channel access. That means we also have to give him an opportunity to put their data packets onto their slots. Alright. Now for which we need the synchronization, and therefore this slot is basically meant for synchronization for the new nodes. So basically let us assume a new node is joining in slot 2. Alright, he will not be able to synchronize. He has to wait for some more time to do a bit of synchronizing. Okay. It's all clear? Okay. Now in each slots, alright, you have SYN, which is a synchronizing channel. Alright. Now here I have given an example of F0 as a synchronizing channel. So each slot has a synchronizing packet as well, alright, which can do a synchronization also. Okay. And what is HR? HR is the hop reservation packet. Alright, now you should recall our objective is to reserve a particular slot. Am I right? We are now in the process of reserving a slot. How? I am now trying to reserve using the hop request. Alright, in earlier cases we had a different terminology. Alright, for this hop request based one, reservation based one, we have the hop request. Then you have RTS, which is request to send, and CTS, which is the clear to send. So how does it operate? You look at this. If one synchronizing slot is allocated, then the whole L-1 frequency are divided into L-1 by 2, which is equal to M, and that's how you slot it. Okay, so you have the frequency is basically divided into M frequency pairs. So that means each operates on a frequency pair. So let us assume Fi, where I can vary from 0 or 1 particular to M. Okay, what is Fi and Fi asterisk? Fi asterisk is basically meant for acknowledgement. Okay, Fi asterisk is basically meant for acknowledgement. So it basically operates on a sort of a frequency pairing. And the sync is SYN is always F0. Okay, now look at the interesting nodes. Now you find that here there is basically a reservation of slots. Am I right? Let us assume this is particular network. This is another particular network. Alright, so you don't have to merge it currently. Now you can look at as two identical networks. So let's say there is a network now, there is a channel now, and in that particular channel now I have to allocate a particular slot for a particular node to pair with others to start communicating. Am I right? So that's what we are doing. Now look at this. This is F0. F0 is basically a synchronizing slot. And then you have F0, F1. Alright, what is F0? F0 is this sync, SYN. Okay, and then you have F1. Now you find how many slots here? How many slots? 5. So that means m is equal to 5. Are you all getting what I'm saying? I got what I'm saying? Slot 1, slot 2, slot 3, slot 5. So slot 1 becomes this one. Okay, and slot 2 becomes this one. So you put slot 1 which has F0 which is in, and the F2 other remaining part of it. And then you have F0 and F3. Are you getting what I'm saying? So this becomes one slot. So that's what it's mentioned here, one slot. So how many slots are available? 5 slots. That means m is equal to 5 I have. Are you all getting what I'm saying? Okay. Now why did I show these two? It's because, why did I show these two? It's because this is one particular network. Alright. I initially said when a new node joins, then it basically does a synchronization. Alright. This will help you to understand how it really synchronizes and merges together. This is one subnet or one network, and we are looking at in a particular node. This is with the other network tries to merge. Alright, now you find there is somewhere mismapping, but then you can easily merge because you have a synchronization packet across each slots and also at the bigger level. So you can easily try to merge. Alright, two different networks can simply merge on a particular slot and try to reserve a particular slot in a particular channel and start to access your data packets, or start to put your data packets onto the channel or send it to the receiver. Is it clear? So this is what is called as hop reservation multiple access protocol. So there is a synchronization slot, you have a hop reservation slot where you reserve a hop, and then you send RTS and then clear to send from the receiver, and then it does it. And in each particular slot you have a frequency different pair, so that's you have to keep it in mind. You find there is in a particular slot it operates at a different. Okay, and the last one for today's class would be the soft reservation multiple access with priority assignment protocol. Okay, soft reservation multiple access with priority assignment. Now there is a requirement here to fix up a priority. Now in all these protocols that we have talked about so far, we never talked about giving a priority for a particular node to pull out or send a data packet. Each one is considered equal, alright, except in DPRMA where we said voice is given priority to the data. Alright, in all the others there is absolutely no priority. It means each one contend for a particular slot, and once they get a slot, you particular transmit your data packets. Now this protocol is basically a protocol which basically gives a priority assignment for a node. Okay, so we are now going to look at in detail how a priority can be set and how does this protocol really works. And it's called as a soft reservation because it handles very softly. Alright, okay, in a very gentle manner. Alright, okay. Now so this protocol is developed with a very important objective of providing integrated services. Alright, alright. What do you mean by integrated services? I want to look at real time and the non-real time application. Okay, in an ad hoc networks, in such a way that you are able to maximize the multiplexing. Alright, what is multiplexing? What is multiplexing? What is multiplexing? So single input is divided into multiple. No. Okay, so let's find out what is multiplex. You have computer? It's taking a long time. Absolutely right. Okay, so basically multiplexing is different nodes trying to send information, all right, and there will be a multiplexer which will take all your inputs from different people, put it all together and then send it, right? So that's basically, you look at this circuit, all right, it basically says you have a source 1, source 2, source 3 and so on. You have a multiplexer, all right. So all these data come together, you multiplex it and then put it in a time frame slots. So that means it's something like you take and then put it at different slots and then send it across, to the particular destination, and there you try to demultiplex it and send it to the right person whom it has to reach, all right. Now in our case, what we basically do is we have an analog, basically it can also integrate analog and digital also together. Okay, so that's subject of interesting. Okay, all right. So now what are we trying to do is you have a real-time data traffic. You also have a non-real-time data traffic. Each comes from a different application in a particular network, ad hoc network. So what you try to do, you try to take your real-time application data as well as the non-real time, and then you put it together, all right, on a multiplexing environment, okay, such that the multiplexing gain is higher. What do you mean by gain is higher? The efficiency is higher. That's what it means. Okay, so it basically says there is a real-time traffic, there is a non-real-time traffic, and when there is a real-time traffic, I give priority to them. Let us assume two of them are already communicating a non-real-time application, having a non-real-time data, and they are sharing across each other. Suddenly let us assume that there is a real-time data is coming up. What's going to happen is we are going to give priority to send the data packet and then keep the others on hold, especially the non-real-time data. So that's the objective. Are you getting what I'm saying? We call it as a multiplexing because we are trying to put real-time and then a non-real-time and then a real-time and then a non-real-time and so on. So we try to put it all together and it's almost like a multiplexer, or we are doing a multiplexing, right, such that the multiplexing gain is higher. Okay, now it also uses a handshake mechanism by which we try to avoid collision, all right. So we also have a handshake and a soft reservation. So let's look at what do you mean by soft, all right. What do you mean by soft is handling them softly, all right. That means rather than giving a very stubborn, stupid, strong answer back to them, trying to giving it on a gentle basis, all right. So let's look at how this gently it really handles it. Okay, now take up this, assuming that you have a frame which has a frame of a length L, all right, and then I have a slot from 1 to n. Now each slot, all right, you have a sync packet which basically does a synchronizing, and then you have a soft reservation, a small mini slot for soft reservation which is called as SR, and then you have a reservation request mini slot where RR you try to send, which is called as a reservation request. RC stands for reservation confirm, which basically is a which does the confirmation of the reservation, and once the confirmation of the reservation takes place, you are able to send the data. So this is a data mini slot or a sub slot, however you call it. Okay, and then your acknowledgement. So you find here a handshake, am I right? The handshake is not in terms of RTS and CTS as we see there, but here we see as a reservation request and reservation confirmation, and then you try to send the data. Okay, so you have a synchronization which basically does a synchronizing. So it basically helps in to a node when he joins fresh. All right, you can synchronize it in such a way that he also participates in the system. So that's given, and then you have SR, RR, RC, and so on and so on. Clear? Now you need to look at SR packet now. All right, or a SR mini slot. SR mini slot, I said it's a soft reservation slot which has a particular field which you can set up a priority value for that. Are you all getting what I'm saying? So you can set up a priority value. Alright. Now let us assume like this. Let us assume that a node A would like to send a data packet, alright, which is a non-real-time application, node A. Alright. And let us assume that the node A wants to send a non-real-time application, and let us assume that its priority is 1, assuming this. Alright, let us assume a node B. Node B, let us assume it also wants to send a non-real-time application data, okay, but its priority is 2, not at the first level but at the second level. Let us assume that there is another node 3 which also wanted to send a non-real-time application data which has a priority of 3. And let us assume node 4 which wants to send a real-time application data, alright, which basically has the highest priority. Are you getting what I'm saying? Maybe we can say priority as 0, which basically says is the highest priority, just for an example case. Now let us assume node 3 is now sending the data. Okay, node 3 is what kind of data it has? Non-real time, which has a priority 3. Alright, so you will find that here in the SR you have a priority bit set as priority value 3. Okay, and let us assume that the one slot basically runs through. Okay, it has a different data it has to send. It basically has fragmented it and it is sending one particular this slot. And the next slot, what basically happens is you have an SR priority value set as 3, and let us assume that the new node B wants to now send it, alright, node 2 or whatever, and then it has a priority value of 2. Okay, so what happens? There is a soft reservation taking place, that the node 2 takes over the node 3 reservation, and node 2, because it has a priority of 2 which has a non-real-time application, it goes ahead and transmits the packet. Now let us assume that at the same time the real-time data is also coming up from node 4. So what will happen if node 4 real-time happens? Alright, all the non-real-time application data packets are kept on hold, and this is taken care of and it is set. Are you getting what I'm saying? So you have a complete multiplexing taking place in order to have a higher multiplexing gain, and it also takes care of real-time application data as well as non-real-time application data on a particular adapter. Okay, so any doubts? So today's class we will stop with this, and the next class we will talk about 5-phase reservation protocol. Little interesting. It basically talks about we have 5 different phases to reserve a protocol, so let's look at that. and we'll also look at MACA with piggybacking based reservation and so on. So we will look at those concepts in the next class. Any doubts?